This is an AS Maths question on trigonometric equations. Part A, show that the equation 4 cos theta minus 1 equal to 2 sin theta tan theta can be written in the form 6 cos squared theta minus cos theta minus 2 is equal to 0. So we'll start first of all by writing out what we've been given. 4 cos theta minus 1 is equal to 2 sin theta tan theta. And I think the first thing I'm going to do is to replace tan theta with sine theta over cos theta. So write that out. So 4 cos theta minus 1 is equal to 2 sine theta times by sine theta over cos theta. So if we multiply that out, we'll have 4 cos theta minus 1 is equal to 2 sine squared theta. And that's going to be over cos theta. I want to get rid of that fraction, so I'm going to multiply both sides by cos. So I will get 4 cos squared theta minus cos theta is equal to 2 sine squared theta. Then I will take the sine squared theta and replace that with 1 minus cos squared theta. So I'll have 4 cos squared theta minus cos theta is equal to 2, and then in brackets 1 minus cos squared theta. So now I've got everything in terms of cos, which is what I've got here. We'll move everything to one side, simplify it, and hopefully we'll get what we need to get. So we've got 4 cos squared theta minus cos theta. Now if I expand the brackets and bring this across, I'll get 2 from here. So I bring that across, I'll get minus 2. And then from here, I will get minus 2 cos squared theta. So I'll bring that across, and then that will become plus 2 cos squared theta, and that's going to be equal to 0. So from there, I can put my cos squareds together. 4 of them there, 2 of them there. So that makes 6 cos squared theta. And then just minus cos theta. And then minus 2, so we get as what they want as required. Part B, hence. Now when you see the word hence, it means look at what you've done before. Solve for x in the range 0 to 90. 4 cos 3x minus 1 is equal to 2 sine 3x tan 3x. Given your answers where appropriate to 1 decimal place. And it says here we've got a warning, basically, which means don't try and solve this by using a graphic calculator or some other method to try and find x which isn't based on algebra and trigonometry. So a couple of things I notice. The first thing, whenever you have this hence thing, it means look at what you've done before. So in the first part of the question, we saw that we could take the equation and write it in a different form. We could write a different form, so maybe we can write this in a different form. If I compare what I'm trying to solve with what I was given in the part A, I notice that the only difference is where there are thetas here, I've got 3 x's here. So maybe what I can do is to take the theta out and replace it with a 3x, and then use what I've got here. So that's exactly what I'm going to do. I'm going to use what I've highlighted in blue here and replace the thetas with 3x. I'm taking this 4 cos 3x minus 1 is equal to 2 sine 3x tan 3x, and use what I had in part A and write that as 6 cos squared 3x. So take the theta out, replace it with 3x, minus cos 3x minus 2 is equal to 0. Okay, one other thing I noticed before I carry on, and that's the range of values I've been given here, x. Now I've got 3x here. So I want to change my range to reflect that and have 3x. So I'll times everything by 3 and I'll have 0, not theta, 0 is less than or equal to 3x, which is going to be less than 270. So that gives me the range of values for 3x. Right, okay, nice little quadratic here. Let's factorize it. So I'll have 3 cos 3x, and I think I'm going to have minus 2, and then 2 cos 3x plus 1. Let me just double check that that expands correctly. Yep, minus 4, then plus the 3. Yep, that works. And then I can look at each part and solve it. So if I start with the first part over here, so I want to solve 3 cos 3x minus 2 is equal to 0, which means I want to solve cos 3x is equal to 2/3. So that's going to be the first equation that I'm going to be looking at solving in a moment. And then over here I will have 2 cos 3x plus 1 is equal to 0, and that will give me cos 3x is equal to -1/2. So this will be the other equation that I need to solve. Okay, so let's start with the cos 3x is equal to 2/3. So I need to do the cos inverse of both sides to find 3x. So 3x is going to be the cos inverse of 2/3. So in degrees I get 48.189 and so on. I want to see if there are any other solutions for cos 3x. I'm going to use a cast diagram, put my angles on. I'm going to draw 48.189 degrees. That's going to be here in the first quadrant. The other place where cos is positive, like it is here, is in the fourth quadrant. Easy way to remember is just if it's cos, you reflect in the x-axis. There's another solution here. However, my range of solutions is only going to go from 0 to 270. That's bigger than 270, so that's no good. Because when I divide the solution by 3, it's going to be too big. So we're going from 0 to 270. So the only one I've got here is this 48.189. So I don't need a cast diagram anymore. So I can divide that by 3 to get a solution. So I'll get x is equal to, so I'm just going to do answer divided by 3. And I get 16.0632 and so on. I want a solution that's to 1 decimal place. So first solution is going to be 16.1 degrees. Okay, so now we'll go on to the cos 3x is equal to -1/2. So cos 3x equal to -1/2. Again, do the cos inverse of both sides. So if I do the cos inverse of -1/2, I get 120 degrees. Okay, let's see if there's any other solutions on a cast diagram. By drawing a cast diagram, 0, 90, 180, 270. So I'll draw that little arc thing I drew. So I only want solutions up to 270, no further. So I've already got the 120. So 120 is over here, which means that this angle here is 120. The one on the other side over here would be 60. Reflect that in the x-axis. There's going to be another solution there. That's fine. Okay, because that's in the range of values, and because the angle going backwards is 120, I can now just do 360 minus 120 and get another angle of 240 degrees. So that's my values for 3x. Get rid of the cast diagram, and so I'll have x, divide those by 3, is going to be 40, and 240 divided by 3, 80. So I can add my other solutions to 1 decimal place. So 40.0 degrees and 80.0 degrees. So there I have my 3 solutions.